We are at Fatih Sultan Mehmet Vakif University, Estelle Laboratory. Here, we will perform air, water, and wind tests of our facade systems, sliding systems, door and window systems.
Our target is Class 9A 600 pascals. We will test it up to 900 pascals. 3 pulses are applied 3 times quickly, up to 660 pascals, not exceeding 100 pascals per second.
This equals a downpour, right?
Yes, it's a downpour, a frontal rainfall.
What is important here is that the system can drain the water.
Yes, the important thing here is, the system can drain the water inside the cabin on its own and not give it out.
Our target was to see 600 pascals. After seeing 600 pascals, we continued until we saw 900 pascals. We successfully completed our water test when we saw 900 pascals. Here, air tightness testing is performed. After successfully completing our air tightness test, we move on to our wind resistance test.
The wind resistance test begins with 3 positive blows. He will do the 3rd step now. We see it in yellow now. He delivered the first 2 blows. He will deal the 3rd blow now. It will rise up to 1,760 pascals. It will wait 7 seconds after exiting. After waiting 7 seconds, it will decrease to 0 pascals again and the pulses will end. From now on, the system will go up to a maximum of 1,600 pascals for deflection and wind resistance. It will do this in all 4 levels. It will wait 7 seconds at each level. It's currently on a 7-second cooldown. After 7 seconds it will go down to 0, wait there, finish the impact part and wait for our command. Our simple blows are over. We will take positive steps. We divide 1,600 pascals by 4. We will reach the maximum in 4 step-by-step steps. There will be 400, 800, 1,200, 1,600 pascals. It will wait 15 seconds at each level. By the way, as this test begins, we have LBDB rulers at the 0 point after the impacts. We have 3 vertical points on our LBDB rulers that will take measurements from here and reset that point. We can receive instant data from these 3 points. It will reset here. When we reach the maximum of 1,600 pascals, it will take another measurement in 15 seconds. We will find the maximum deflection from now on. 0 pascals will decrease from 1,600 pascals. There will be no pressure left inside. After waiting 2 minutes like this, it will take another measurement. In this measurement, it will measure whether there is any permanent deformation in the profiles, if any. How much deflection, i.e. relative to the first 0 point. It will show whether there is any deflection or permanent deformation left after the impacts compared to the 0 point. The same cycle will happen in the negative.
What kind of wind does this 1,600 pascals equal?
We can see here 1,600, 800, 2,400. This is the recipe requested from us, but it can be divided like this in the intermediate steps. Let me put it this way: the maximum is Class 5. Class 4 is a lower level of this. It is a Class 5 high hurricane pattern. Class 4 corresponds to a moderate intensity hurricane. This is required for high-rise buildings. Class 4 or Class 5 is required. It is one of the standards required after approximately 30 meters. Class 4 or Class 5 is required for buildings higher than 30 meters. Class 5 is mandatory in 100-meter buildings. Class 5 is mandatory in skyscraper-style buildings, but these are good values for buildings higher than 30 meters. Now we are coming to 1,600 pascals. We will wait 15 seconds. When we see 1,600 pascal, it will decrease gradually.
Now it will drop back to 0.
It will drop to 0 and wait. It will count. We passed 15 seconds. It will count again after it reaches 0. Now the negative test has started. We have now completed the positive and negative wind test and deflection test. We will begin repeated pressure testing. In this test, we will go down to minus 800 pascals and go up to plus 800 pascals. In this way we will repeat this cycle 50 times. So it's always minus 800 plus 800 minus 800 plus 800. It's going to come and go. He will have done this in 50 cycles. It will wait 7 seconds in between when it goes down to minus 800 and goes up to plus 800. So it's a pretty fast, dynamic test.
Now, we see the glass stretching as a result of impacts.
Our positive and negative deflection test is finished. This was step 1. The second step was our loop test. It also passed our 50 positive and negative loop tests. After this, we will go back to the beginning of this process and do the air tightness test again, going back to the beginning. First 3 positive impacts, then a positive air tightness test, then 3 negative impacts and a negative air tightness test. Here we are expected to catch class 4 again. The difference between this test and the first air tightness test we performed should not exceed 20%.
So in these tests, whether attrition is above or below 20% will be checked, right?
Yes. In these tests, we mechanically fatigue the system. With the deflection test, profiles, wicks and accessories all work dynamically. In repetitive pressure testing, we make ourselves more tired by regularly changing the pressure repeatedly. We checked it, there does not appear to be any malfunction. In the meantime, we will test again to see if there is any loss in air tightness. After this test, we will do the security test as the last step.
Our system has successfully passed the wind resistance, wear and security tests, and has successfully completed the water tightness, air tightness, wind resistance, wear and safety tests. Thus, our system has been certified to be resistant to heavy rain, moderate hurricanes and weather and wind, even in buildings 100 meters high.